Hello. Good morning, everyone.
Hi.
Hello.
Hello there.
So maybe we'll just wait a couple more minutes. Okay, I think we can get started. Let me share my screen for today's agenda. Hey, can you guys see my screen?
Yeah.
Yes.
Okay, wonderful. Yeah, I got a few things today. I'll just have some quick update about the OCP Global Summit, and then we have a few work items we want to follow up for the schema from the proposal from Keysight, and also we want to talk about our AI infrastructure white papers, especially scale up versus scale out. There's quite some discussion here, so we like to look into that document to see how we move forward from there. And then I also want to have updates from work streams like neuromorphic computing, simulation, and data services. Oh, where is it? Okay, so in the past few weeks, everyone is busy with this preparation for OCP Global Summit. So I think now all the agendas and presentation materials are pretty much settled. And then the schedule is in October 13th or 15th. So just like a few weeks away. And now with that been settled, so we can maybe just wrap up this agenda for OCP, Global Summit. So we also published this OCP blog last week. Thanks, Jack, and also the team to authoring this blog. And I hope that, especially the participants for OCP help propagate the message. And I don't know if you guys saw this in the OCP website, but I can just paste the link here just in case you want to share this in your social media. Okay, let's move on to the next one. It's about the schema update. when we publish this blog in my LinkedIn, actually, at least I saw one comments about how do we describe our infrastructure so that we can have a apple-to-apple comparison. This actually is very in line with the current work, especially the schema proposal from Keysight. And with this, hopefully we can standardize our description on the AI infrastructure, and that will certainly give some foundation for future comparison. And in previously, people already give some comments about the schema. I think Yasa mentioned something about hierarchical description, and that was also addressed by the Keysight team. And I also look at the current proposal, maybe the current version of the proposal, and I provide some feedbacks. Maybe we can have some update from Keysight team.
Sure, Vipin. Yeah. So
You want to
thanks.
share screen or you just want to?
No, I'll give you the verbal update first.
Okay.
So we got your feedback and thanks for that. Those are really helpful. So as I mentioned, like we addressed a few of them already in our refresh that we have been actively working on. We received some feedbacks from Prakash also. Last time also we talked about them. We tried to address few of them. Not everything is done, and it will require more iterations in the community. We will need more discussions and all, but uh, we will um, we will publish one that we are actively working on. There are a few changes already made. Within like as I mentioned in while replying to you, few new concepts have been added, and also as you mentioned, like if there is any visualizer or any tool to view, so those kind of things should be easier with the newer version that we are working on. So the plan that we have, we need to publish that before the OCP. We need to use the new link. We are not going to use the same link where it was earlier. We came up with a new domain for that, like infragraph, and the plan is from our side, we will publish maybe by mid next week or so, and then it might be easier for take further feedback or take it for a review or uh, probably post OCP. That's something we will continue there. Um, Yeah, so primarily that's the update. Last couple of weeks, we had been little busy with some other activities internally, but we did good progress in the infograph. Um, and that is kind of in place. We are doing some internal reviews again, and hopefully by next week we should be able to publish that and share the links to everybody here.
Great. Thanks for the update.
Mhm. So one thing to Jesha, like the newer version that we have right now, there might be some minor, or there will be some minor changes in the slides that we have. First of all, the links that we have there, we will be changing them. Um, for the infograph newer version, the GitHub link will be different, and also the example that we have, there are some nitty-gritty needs to be there. So we will share that. I think the final version needs to be submitted by 26th of this month, right?
Yeah, that is correct. Though, let's just say
So
that I'm planning to include some more updates on myself at the start of October because we're still running more analysis, and I don't really see why I should keep outdated results in the figures. So they give you an option to in person go to them on the Monday of OCP and just give them the updated PowerPoint. So I will do that. for my own results at least. Yeah, if you could send me yours until say the end of September, that would certainly be helpful just to make sure that there's no kind of crossover of
Sure.
versions and stuff.
Sure, we'll share that earlier.
Okay, cool.
Great. Can you also share your like next step, the plan after we get the schema, and what are we going to build on top of that?
So we will also provide some services in that in the same repository, and also at least to start with, we'll give at least 1 or 2 examples with some simple cloth fabric or some other type of simple fabrics. Also, we will try to get some examples, might not be on the very first day, but at least these concepts like composability and hierarchical topologies. So those things will keep on coming, means we'll keep on adding, and also we will take reviews and all. And probably like before OCP, I don't think we will be able to present the things here in this group, but post OCP definitely we will try to present it here and get further feedbacks. So that's something we can do and iterate over it. But before that, we'll share the link once we make it public.
Okay.
Yeah.
So when you talk about the example, I wondered if we can use that to describe some like recent kind of like a supernodes from NVIDIA. I'm just wondering because NVIDIA is going to publish this supernodes in next year. So maybe people will, trying to build their roadmap or plan according to this new release. So if, let's say, if we are able to use in your schema somehow describe this and people may, do simulations or some kind of a planning based upon this, hopefully this may give, more motivation for people to leverage in this new schema. I don't know if this makes sense or people feel like this is something we want to do at, as a just example access of your schema.
Yeah, once we make it public, then maybe we can have those discussions and see like how we can get those examples implemented in using the infograph. Those can be, but we will discuss the details, and we'll try to get that.
Or maybe based upon your schemas and, people from this group can just use and leverage in that schema and then, build the example ourselves. I don't know if
Yeah,
is this something interesting to the team.
yeah, it would be interesting. We will add sufficient documentations also, so that somebody should be able to follow it. But
Yeah.
yeah, definitely we can work together also. But if somebody wants to try, definitely.
Okay, sounds good. So we'll wait for your release in next week.
Yeah.
Okay. Let's move on to the next topic about this scale ups versus scale out. I saw there was quite some discussion in work groups email threads. It's quite long, so I'm not going to show the contents here. So I saw Jay is also in today's meeting, so maybe you can help update some of the sections in a white paper. I know this is actually a very important part of the white paper.
Yes, if I'm gonna do that, is there a timeline we are looking?
I'm thinking that maybe by the end of the year, the calendar year.
Okay, so not before OCP, right?
No, I guess OCP probably you have enough material or any points you want to cover. That probably is enough for the presentation. But I'm look at this more from white paper perspective.
Yes, I think uh, I'll start adding sections to it. I think I can do that, definitely. And this sheet is being shared, right?
You mean which one?
The one you are flashing on where the link is there. I need
Oh, here.
okay, I need a link to the document.
Okay, let me just repaste this.
You got it.
Yeah, I think there was also, especially in the scale out section, let me just move to that page. I forgot which page. Oh, right here. Also, there's partial updates from or MIPS, sorry, about this some of the some like white paper they published.
Yeah, that's the convergence stuff last time we talked about. So I'm assuming that J's section J will cover, right? Last time I was asked to include that, but if you can scroll up, there is a J's section here, which J never filled up, I think.
Yeah,
Go before that.
right here at the top. I think
Yeah,
maybe
so
after your section there was some description from Jay.
yeah, I don't know now, probably it got changed, but in the last meeting, there was a section, I think, before my section. My section is the convergence. And before that, there was a scale up and a scale out. I think a scale up section was there, which I think is got modified because in the last meeting, Jay was not there and somebody asked me to kind of include that.
Okay.
But whichever way, I'm fine, either way. Or maybe scroll down, is it after this? I thought it was before that.
Actually, I think it's after yours.
Okay, maybe I'm mistaken then.
Are those like
There was a scale up, I think, where Jay's name was.
yeah, there was but I think you add your section right after that title.
Yes,
Yeah.
that was
So
right.
that's why
So that's,
the original content was behind follow your description there. But anyways, this page is too long for me to
yeah.
scroll up and down. So oh, also I add some description here, so I'm not sure people get a chance to look at this. Okay, so this is basically in the suggestion mode.
Yeah, that's the section I was talking about. See here, it's the
Okay.
J's name there, scale up J. Yeah.
Okay. Yeah, basically, I add this section during the weekend and trying to characterize what is the common idea for people to think what's scale up and what's scale out. This may not be very accurate, so that's why I wonder if this group can help really identify the exactly definition of a scale up or scale out. And then maybe we are able to define what it is and what it is not. So this way, at least we have some foundation to discuss.
Yeah, I can do that, Wei-Feng. So I saw there was some conversation on the email as well, trying to characterize it. And it depends, right? A lot of people come from a different background and they may think it in a pure computer sciences kind of a term. But you're right. In the ML fabrics, the meaning is a little bit more technical and it's kind of sticky to some constructs. So I will expand this section as an introduction where, create a baseline for the definition of scale up, what it means and what scale out means. And what it will do, it will kind of create a good basis for, further sections and also for Prakash to expand on it. And I think we should review that.
Yeah.
Right. So once I do that, then I will request a time for review. And that's going to be probably after OCP.
Yeah. And there was one more thing, I think there was Excel sheet got created during last few
I
meetings.
saw that. Yeah. And that's what I was saying, that it's sort of a kitchen sink coming from different backgrounds. So not everything is applicable. And that's a little messy. I looked at it.
Yeah, no, I was asked to fill one row on that, so I just put the converged scale up, scale out rows as well there. But yeah, it is like a kind of networking people versus the compute people. So both terms are mixed up in this and this.
Yeah. I mean, even the ordering, like I see this compute bound, memory bound. I mean, these are low level constructs, and they depends on a given workload placement on how the hardware is orchestrated, even within the scale up. So I don't agree with all of this, and it's very hard to quantify. This is a very fast changing field. So if we kind of put a hard boundary on these definitions, they will become stale pretty fast. So that's why I was not very waving. I saw this. I was not very excited about it.
Yeah, I know Jack created this spreadsheet. I don't know what is, I don't remember what is the original motivation for us to
Original was the same discussion which we had, I think, a couple of weeks before, where everybody has a different idea of the scale up and the scale out. And then I think Jack took an action item for him to start this spreadsheet. And where I think last time we were looking into and discussing. So I think it's, as I mentioned, it's more like a compute perspective versus network perspective. And somehow we need to merge them together because now network is compute.
Not necessarily, Prakash. Not necessarily. I mean, I won't create that boundary. The only thing is, like, if you see that there is out of order semantics or in order semantics for memory bound or compute bound, right? Those and the synchronous. I mean, that's maybe true today for certain workloads and certain deployments. May not be true for a lot of other deployments.
Right.
So that's where my concern was coming. That
Yeah. Now, when I was filling that, I was thinking like, oh, I need to write as needed everywhere. But then I said, okay, we'll put the best, best way things
So I
will be
think
going.
I'll keep this sheet the way it is. I probably won't incorporate this, but I'll incorporate what typically in the conversations, like if you talk to OpenAI or X.AI, right? What understanding of scale up means, right? And it's a very crisp definition, right?
Yeah, I think there was in the last week AI conference, there was a presentation by, I think, Ram. Is it Ram from Broadcom? Yeah. I think it's been defined, which is not different than at least what I was thinking. But one thing, Jay, on that thing, I sent a couple of weeks back 2 slides. Like one was on the definition and other was on the convergence section, which I put together. You can look into that, and wherever you think it can be accommodated, whichever way, you can look at those. I sent you and Samantika. I think that time I was told to send both of you, so I sent.
Right. Yeah, I looked at it. Yes.
Sure. Yeah.
Okay. So, Vipin, coming back, I will leave this the way it is, this Excel sheet, but will provide text with proper references why that definition of a scale up is the way it is being captured in this document, right?
Okay.
So if people will have it's not that something which I'm smoking, it's probably something what wide set of people are smoking. So that way it will be, people can cross-check or cross-reference.
So where is this spreadsheet? Maybe you have a link to the spreadsheet?
The spreadsheet is in that WIP folder. So if you,
Okay.
yeah, this
Can
is the
you,
shared drive, right? There's multiple folders here. I think we
Yeah.
shared this before. So if you just go to this work in progress folder, and then there was multiple documents. So this is the one we were talking about. We like to, finish this white paper by end of the year.
Okay. Okay.
And this is the spreadsheet we just talked about.
There is also a scale across and a scale beyond. So scale up, scale out, scale across, and scale beyond. Have you heard of this?
Is that kind of a formal term or it's more
Yeah. I attend different conferences and seminars, and they talk about it.
scale beyond?
Is
Yeah,
that
scale.
like into data center, like scaling
Yes,
between different
exactly.
geographical
Like,
data centers? Yeah.
yeah,
I heard of that.
scaling across data centers,
Hmm.
scaling beyond, like maybe a whole city or a country.
Yeah, I think OpenAI have been pushing the concept of like models that are geographically distributed over multiple centers, and then you need like algorithms and infrastructure to link those together and get even
Yes,
capacity, which is it's another bet on like scaling, right? Scaling laws.
So this is more kind of like a traditional network, like zones, or even beyond that zones concept.
yeah. I actually heard it last time. I heard it from Ultra Ethernet Consortium leader. He's from AMD.
Yeah, Hisham, I can say I'm part of UEC. I chair a bunch of groups there. Yeah, I think, it's basically when I didn't want it to open the can of worms. When we when we talk about scale up, scale out, or scale out beyond, right? Scale beyond.
Yeah,
Uh,
exactly.
right. So the reason there are things which come in play. There is a characterization of the compute interconnect with the GPU and the fabric. If there's a rack, right, then the scaling limitation in terms of the reach, right, then copper optics, and now a lot of people are talking about optical connectors, not just the
Yes,
optics.
yes,
So like an optical OCS kind of a optical compute switch, right? Uh, and those characterization get different in different setup. Like when you say scale up, then that characterization is quite different than scale out and then scale beyond, right?
yes,
I would keep beyond out. I mean, let's not go there yet, okay? But there are things which will not change between scale out and scale beyond, like the transport will not change. You still have a RMA kind of semantics. Just RMA is not going over a cluster of kilometers. It may go over, hundreds of kilometers.
yeah, you're right.
But still remains RMA. Versus when you scale up, then scale up does not have a concept of RMA. It's a direct memory access kind of a load store, right? So that's a very fundamental difference, and that stays between scale up and out. Scale out and beyond looks very same except for the interconnect. It does not have an implication on the transports. It have a different kind of congestion control, becomes a little bit different. Multipathing becomes like over DCI, interconnect, etc. But the basic constructs remain same. They don't differ much. So I will put scale out and scale beyond in on one bucket right now, and don't talk about scale beyond. And I would suggest not to confuse with it right now, if that's okay. But
Yeah, sure.
but the
yeah,
up and out, they have a fundamental difference.
and I think fundamental difference related to memory semantics, right? As you mentioned, Jay.
No, fundamental differences are in terms of not just memory semantics, the requirement on congestion control, the requirement of number of tiers you want, the reach you can have,
Exactly. Yeah, I agree. I
right?
agree.
The coherency you want, those kind
Yes,
of things. When you go
I
scale
agree.
out, you cannot have a memory coherency, right? You cannot have
Yes,
a coherent domain, things like
yes,
that. So
exactly.
those are the fundamental difference, and that's what I will capture in this introduction, which creates a baseline.
Excellent.
Yeah.
That's exactly it.
Yeah, but please don't go scale beyond. don't make yourself
Yeah,
crazy on that.
yeah, but the guy, you know him, is a guy from AMD, Mats.
I know
When he gave,
JMS.
yeah, you
Yeah,
know him for sure.
yeah,
So he's leading UEC, and he started to talk about scale across and scale beyond.
correct.
It's the first time for me to hear it, honestly.
Yeah. But that's something which is, and the reason we are talking about it, we talk about 1 million endpoints in a scale
Yes.
out, and 1 million endpoints creating within a certain scale out domain is becoming impractical because of power reasons. Then you want to go scale beyond,
Yes,
right?
exactly.
Yeah. Anyways, okay. Sorry, I didn't want to go in that detail.
Okay, so maybe we can have more detailed discussion on this, especially after OCP Global Summit. And then our goal is trying to finish this white paper by end of the year.
Sounds good.
So, yeah. So we got almost like 2 months. Okay, let's back to this. Okay, so we can have more updates on the other work streams like neuromorphic computing and simulation.
Yeah. Do you want me to give you update?
Yeah, sure.
Yeah. So as you know, we just finished a call today about neuromorphic computing, and it was very well attended. Maybe of more than 40 at the beginning attended. And the discussion was around what do we do with neuromorphic computing now and in the future, which are two issues that need to be covered in the white paper. That really the main issue now is how to get more people to work on it. So hopefully after today's meeting, more people will sign up to work on this work stream so that we can finish the white paper as soon as we can.
Can you also outline what the overall kind of goal we want to achieve or what type
For
of
the white
output
paper,
we want to
for the
have?
white paper, the goal, as I mentioned in today's meeting, what
The
are we
white
doing?
paper?
Yeah, it's a white paper,
Okay.
exactly. But what we cover in the white paper will be, I will publish this in details, but essentially what is being done with neuromorphic computing now, and what is the prospect of using it in the future in building AI systems using both software and hardware. But to address all the issues that we need to address in the white paper, we need a team. Right now, I see people who are interested, but I'm not sure how they are committed to work on the white paper. That is the main hurdle I try to overcome.
Yeah, so Hesham, it can be considered as an extension of the AI work, because I think the main message in today's presentation was also how to address the power issues, right?
Yes,
The
exactly.
power consumption issues.
Yes.
So looks to me it's quite related to the AI or AI fabric work we are doing. So it can
Yes,
be.
it is. Absolutely, it is, Prakash. Yes.
Yeah.
I think one of the challenges, Hesham, is when it comes to neuromorphic computing, you'll have as many opinions as you do participants.
Agreed.
Quite
Yes.
difficult to actually get people to sort of come together and produce something that is useful
Exactly.
and aligned. So I think for me that seems to be I would be happy to participate, but there needs to be some kind of ground rules or useful goal or constraints that sort of help
Yes.
us be
Yes.
productive. and not just
Yeah.
like argument talk.
Exactly, Dan. And as you've seen it today, when I mentioned to Steve Farber the opinion of David Patterson and Bill Daly, he disagree with them. So there are many opinions, and you're right. We need to converge on one unique view or vision for the future, which is difficult to do.
Yeah, but I think this problem statement is pretty much like contained or very crisp in that how to address the power consumption in
absolutely.
AI fabric.
Yes.
So if
Yes.
we take that one, we have the goal now. Okay, how we can use the neuromorphic computing or whatever the spiky.
Well, that
Yes.
part assumes that neuromorphic computing is the solution to that power problem.
Yes.
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 So,
Yes.
so either we take a view that if the problem statement is sort of power consumption, system lifetime, those kind of cost issues, and address that, or we decide to ask the question or answer the question, what is the relevance of neuromorphic computing? Those are two different questions.
Yeah. Good point. Good point. And instead of we can just focus on energy consumption as one of the goals. And
It's a coding pattern that matches things like
yeah.
event-driven simulation. So
Yes. Yes.
the question is, how do you make neuromorphic computing general purpose to some extent?
Yeah.
Yeah, and that's quite a challenging question to sort of answer in a white paper.
Yeah.
I can do it. Done it before.
Yeah, sure. Kevin, if you have some write up, please. I think it's the right
I
way.
told Paul Borrell I'd do it for his chiplet summit, so we'll see how that goes.
Yeah. Okay, good. Good.
Okay, so you're going to do that, and then we can critique it and help. Is that the idea?
Yeah.
Okay, Kevin, so you are going to there's a document in this folder, work in progress, neuromorphic computing. You can think of this as a base, or if you can start from scratch. Either way,
Yeah.
can you put down something so that maybe we can discuss in next meeting?
I'm traveling at the moment. I'm not sure if I'll find time for the next meeting, but I'll see what I can do.
Okay.
Yeah. And
Very
yeah,
good.
if there's we are forming a team or something, I will be probably definitely interested in the energy consumption issues. Whatever we
great,
can do.
Barakat. Okay,
Yeah,
we can work
neuromorphics.
together on this one. We
Yeah.
can work together on this energy stuff. Yes.
Sure. Yeah.
So are we pretty much settled on this problem statement that using neuromorphic computing to address the energy consumption problem for AI infrastructure?
Sure. That is key advantage of neuromorphic computing anyway.
Yeah. Yeah. No, I think this
So
is a very crisp definition, and everybody will be looking at all the data center today or the AI infrastructure
exactly.
wasting or producing a lot of
And given the huge power consumption of AI systems, trying to find a solution to reduce energy consumption and reduce carbon emission is really a very good goal. And if neuromorphic computer can help, that will be an attractive way to get people to look into it. I agree with you.
It's a very similar thing to doing in-memory computing, where you try not to move the data and you move the work to the data.
Yeah.
It maybe needs a different name from neuromorphic computing to be more general. But...
So Ravindra said he's interested. Are you interested in neuromorphic computing or energy consumption? Ravindra.
Hey, yep. So this is my first meeting. I work for Dell. So I know Jack was part of this subgroup. So my background is more likely on the hardware, compute, storage, and on the networking, but more on compute. So I'm certainly interested in neuromorphic computing area.
Send me an email, please.
Sorry?
Send me an email. I'm going to give you my email address.
Yeah.
Excellent.
Yeah, welcome, Ravindra, to join the
Thanks,
group.
Wei. Yeah, Wei said you took over this subgroup that way, Jack. So yeah, we both work at the same company, Jack Hardwood.
Thank you, Ravindra.
Okay, so now we kind of narrow down this neuromorphic computing to one particular aspect, focusing on energy consumption. So then, so this way, instead of just have a very broad topic, so we'll come back to this from next meeting. So hopefully Kevin can put on something we can, as an initial point for us to start.
One more thing is that on October 2nd, I am bringing the co-founder and CTO of Light Matters to talk about their technology with the idea is that they, at some point, they may evolve to use this technology for neuromorphic computing. So that will be really interesting talk. And we can raise the issue of power consumption in this meeting as well.
Well, I think one of the things in neuromorphic is the high fan out on the neurons sometimes. And where you have a high fan out, you want something like photonics or radio for that.
Of course, it helps a lot.
Okay, good. So at least we agree on this particular aspect. It's good. So let's move on to next simulation. I think this, Yasa, this is related to your work, right?
Sorry, I'm walking to the train station right now, so I'm not sure how good you can hear me, but that might be. I mean, simulation is, I guess, indirectly what we do at least. Yeah, so our main paper just got accepted at NeurIPS, so that's very good news. So very excited about that for the team. And so that makes our life significantly easier because now we don't have to restructure everything for iClear, but can move on to the LLM version of it and the large-scale HPC deployment version of it. Obviously, this will be contained in the OCP talk, so people will get the overall update on results at the talk on the big Wednesday breakout session. But yeah, I can also send around the updated manuscript once it's done. Probably first week of October. We have to put some of the additional rebuttal analysis into the main manuscript. So the thing that is on archive is now somewhat outdated, but things haven't majorly changed. So yeah, I think that's probably the update from our side. Yeah, does that make sense?
Is this the one? Or no? Oh.
Sorry, what?
Oh, okay. I was looking at this new post, new chat. I thought it's your post. Oh, it's a different one. This is about neuromorphic computing. Okay, so maybe you can send out the link to the manuscript in case it's available for us to look at.
Yeah, I mean the baseline manuscript is the one that I had already presented on, like what was that 3 weeks ago or something. So it's linked in the old presentation, but we're in the process of updating it now because obviously you run rebuttal analysis, right? So these aren't contained in the archive version yet. So we are updating the archive version for the NeurIPS rebuttal. Camera ready version, which is mid-October, and then we're going to have the updated version. Of course, it's going to be shared with the team once that's online, so that people don't have to wait for NeurIPS in December to see the updated results.
Okay. I also wonder, how is this simulation work related to our schema proposal? Are we going to use that schema as like input to the simulation?
Yeah, so we can do that as an input to get the deployment pattern out. We probably will need to have this the hierarchicalness in that I mentioned via email. So I'll have to look and possibly maybe sync with the Keysight team to which degree that has been addressed. I know that it has been said that there's been some developments with regards to implementing that. So when that example, then the specific hierarchical example is available, I wanted to work through it myself and see to which degree this now matches what we need. But yeah, we can use that schema. Like, long story short, we can use the schema to then essentially predict the deployment pattern on top of that schema once the schema is available. If that makes sense.
Yeah. So Jesha, one question here, like in AstraSim, there are few backends, right? NS3 is one, then analytical, and then there are a few more, like HTSIM is also kind of part of it as a backend of network simulation. So when you are talking, like, are you targeting any specific backend, or I'm not sure, like how?
We are flexible. So there's I'd have to look into. Well, I can come back with you with the detail on which one we are currently running. We found that one of them just runs the quickest, and I think we've had them all running. I mean, for us, it's sometimes when you iterate over the algorithms, you just in the first instance want the speed of getting the data in the first instance, and then you do fine tuning of the high resolution stuff later. So we don't do the highest resolution one. We do one of the kind of mid level, which gives you like a good trade off between them. But if you had a specific preference of what you think works best with you guys and stuff, happy to fine tune to that.
Sure.
No.
Okay.
Yeah, I was thinking that if we have the schema, this is more like AI model written in Onyx syntax, right? And then you simulate load this schema, then you basically initiate a simulator. Now the chakra could be as a actual functional input so that you can run in the AI model. So this is like two different scheme, right? So this way we can standardize the overall the simulation flow.
Yeah, so it's a mix between a simulator and a neural network predicting the deployment straight away, right? So like we don't simulate it all. Essentially, there's like heuristics which do graph processing and give you a solution. So you don't, because otherwise you end up like if you think about the search base of architectures, that already is a bit uncomfortable. But now you have an algorithm graph matched to a hardware graph, so that gets you a really uncomfortable combinatorial explosion. So you better have some good heuristics to cut off certain parts of the search base. So that's kind of what we do with some heuristic algorithms alongside. So it's a mix of directly simulating, and especially I know as Dan Wilkinson is very interested in the dynamic deployment throughout. Well, you can't currently, if you want to do dynamic adaptation of the deployment pattern, you can't fully do that through just simulation because, well, your simulation has to run really quickly for that to be deployed alongside from the actual algorithm, right? So the heuristics are at play for handling the dynamic cases.
Okay. Sounds good. So I think we can, put all those pieces together and maybe formalize as some formal flow for us to really from this schema all the way to actual simulation. Okay, can move on to next one is a data service. I don't know if Jack is I know Jack is working on this data as a service. So I don't know if he's in a meeting today. Let me see.
I don't think Jack went today.
Okay. If
So,
not, then maybe I'll skip the update on this. Okay, we got a few more minutes for the group. I don't know, do you guys have any other things we'd like to discuss?
I have one topic. I joined some of the SOC meetings, chiplet meetings actually, chiplet economy meetings. So that there are also quite a lot of hardware software co-design topics on that level. I'm just curious, this group is more on the probably a more higher level or more infrastructure level. Actually, both say infrastructure, but the chiplet is more on a more detailed level. So how does the two co-design work together, process-wise?
Okay, at least from the work group perspective, we do want to work on all those like basically a full stack of the computation. That means from the chiplet level to the system to nodes, super nodes, a cluster, all the way to data center, and some people talking about like a scale beyond, right? But we are focusing on like a scale up, scale out at this point. This doesn't mean we just want to basically have very concrete deliverables for this year, right? So in case we have a more kind of macro level of co-design, that's in general we feel like the general principle also applies here. So I would say that if there's enough interest on that, macro level, macro architecture level of discussion, that's also fine with us.
Yeah, there are use cases, for example, skill up, because there's some discussion about, chiplet, how, especially memory chip, right? So when you have AI use cases, doing benchmarks, it's possible to scale up some of the memory chips so that there's also a UCIe protocol for chiplets. So how to dynamically adjust that design and use cases. Yeah, so that's kind of a skill up related topic as well there. So I don't know. So the design, the topics here, which is mostly covering like remote memory, etc. So yeah, I guess I just want to bring it up, and I guess at some point the two might need to come to the same junction, one way or the other.
Yeah, we can probably discuss this more on this topic. So if you can come out some proposal, what type of a scope we like to work on, that's also fine. We can maybe start a new work stream from next year.
Okay. Yep. Thank you.
Wifang,
Yes.
I have an issue I want to discuss with you and the team.
Mm-hmm.
So, Professor Muriel Medard, she is now heading or CEO of a new company called Optimum to create the memory layer for Web3. Fine. Then I discussed with her about the memory layer for AI applications, which exist. And the discussion was around how we can use our random linear network coding to optimize the performance of the memory layer of all these Gen AI applications or AI applications in general. And she agreed with me that this is a good use case to address. So is this group, Wolfgang, willing to look into network coding or in particular random linear network coding to optimize the performance of AI infrastructure, the network layer of AI application, or memory layer of the infrastructure used by these applications. Or that is something out of scope of this group.
Okay, can you send more details, or do you have
I
a
will.
pointers
Yes,
to...
I will. I will send
Yeah.
you an email. Yes.
Okay,
I,
that'll be
I will
great.
send. I will send you an email, Wolfgang, about what do we mean by the memory layer for this AI or Gen AI stuff, and current thinking of using network coding to improve the performance of this layer.
Okay.
And you decide if this is within your scope or not.
Yeah, okay, send me the
I will.
and then I'll take a look, and then maybe we can have a follow-up discussion on that.
Sure. Thank you very much.
Thank you. Okay. Anything else? If not, and then we'll just give back 2 minutes to you guys, and then have a great Friday, have a great weekend.
Yep,
Thank
thanks.
you. Thank you. Bye-bye.
Bye.
Thanks, guys. Bye.
Thank you.